Picture a future where humanity's next great treasure hunt doesn't unfold on Earth but among the stars. Scattered across our solar system are asteroids, ancient rocks holding untold riches, from precious metals to water that could fuel our journey to the cosmos. These celestial bodies might just be the key to unlocking a new era of exploration and prosperity. Today, we're diving into the thrilling world of asteroid mining. What these space rocks are, what treasures they hold, how we might extract them, and what this could mean for the future of our species. This isn't just science fiction, it's a bold vision that's closer to reality than you might think. So let's embark on a journey to discover the treasures waiting beyond the stars. Let's start with the basics. Asteroids are rocky objects orbiting the Sun, mostly found in the asteroid belt between Mars and Jupiter. They're remnants from the solar system's formation, about 4.6 billion years ago, when leftover material didn't coalesce into planets. Some asteroids are tiny, just a few meters across, while others, like Ceres, are massive enough to be classified as dwarf planets, stretching hundreds of kilometers wide. Pretty fascinating, isn't it? Far from being mere space debris, asteroids are composed of a variety of materials that make them incredibly valuable. Scientists categorize them into three main types. First, there are C-type asteroids, rich in carbon and volatile compounds like water ice. Then S-type asteroids, packed with silicates and metals such as iron and nickel. And finally, M-type asteroids, which are metallic and loaded with rare elements like platinum and gold. It's amazing how diverse they are, don't you think? These compositions aren't just scientifically intriguing. They're a potential gold mine, both for Earth's economy and for sustaining humanity's ambitions in space. Imagine an asteroid packed with enough water to fuel a fleet of spacecraft or enough platinum to reshape global markets. That's the promise of these cosmic relics. Incredible, isn't it? So what makes asteroids so enticing? Well, it's all about what's inside them. Let's start with the metals. M-type asteroids, in particular, could contain vast amounts of platinum, gold, iridium, and other rare elements, potentially more than all the reserves ever mined on Earth. And platinum, oh boy, it's a big deal. It's used in everything from electronics to catalytic converters to medical devices. A single medium-sized asteroid could hold billions, maybe even trillions of dollars worth of these metals, though flooding Earth's markets with them could shake things up economically. But, metals aren't the only prize. C-type asteroids are loaded with water, often locked away as ice. And in space, water is a game changer. It can be split into hydrogen and oxygen to create rocket fuel, providing a way to refuel spacecraft without relying on Earth. Pretty incredible, right? Water also means breathable air and drinking water for astronauts, making long-term missions far more feasible. Picture a future where we don't need to haul every drop of water from our planet. Instead, we mine it from asteroids, turning space into a self-sustaining frontier. Beyond water and metals, asteroids contain more common materials like iron, nickel, and silicates. These could be used to build structures in space. Think solar panels, space stations, or even entire habitats, without the massive cost of launching materials from Earth. The idea is simple, but revolutionary. Instead of carrying everything with us, we use the resources already out there to build humanity's future among the stars. Now comes the million-dollar question, or rather the trillion-dollar one: how do we get these resources? Mining an asteroid isn't like digging a pit on Earth. Asteroids are in constant motion, orbiting at high speeds, and most lack significant gravity. Plus, they're often millions of miles away, making every step a logistical challenge. But scientists and engineers have some bold ideas about how to make it work. One approach is surface mining. A spacecraft could land on an asteroid and deploy robotic tools to scrape, drill, or blast material from its surface. For water, the asteroid might be heated to release ice, which could then be collected and processed into liquid or gas. And for metals, robotic arms could cut chunks or grind the rock into manageable pieces. It sounds straightforward, but in microgravity, even simple tasks like drilling can send debris flying, clogging equipment. Another method is in situ resource utilization, where the asteroid is processed right where it is. Imagine a spacecraft enveloping a small asteroid in a giant bag. heating it to extract gases or molten metals, and collecting the results without moving heavy loads. There's also the concept of asteroid redirection, capturing a small asteroid and towing it to a closer orbit, like around the moon, where it's easier to mine. NASA has explored this idea with projects like the Asteroid Redirect mission, though it's still in early stages. Each technique has hurdles. Asteroids spin, making it hard to stay anchored. Their surfaces can be loose rubble or solid rock, unpredictable until we get there. Dust is another issue. It's abrasive and can damage delicate machinery. But with advances in robotics, artificial intelligence, and space propulsion, these challenges are starting to look solvable. We're not there yet, but the blueprint for asteroid mining is taking shape. Believe it or not, we've already taken baby steps toward asteroid mining. Space agencies and private companies have launched missions to study asteroids up close, laying the groundwork for future extraction. One standout is Japan's Hayabusa 2 mission. In 2019, it not only landed on the asteroid Ryugu, but collected samples and brought them back to Earth. Analysis revealed Ryugu's riches: carbon-based materials and traces of water, proving asteroids could be resource gold mines. NASA's OSIRIS-REx mission is another milestone. It visited the asteroid Bennu, a carbon-rich rock, and returned samples to Earth in 2023. Bennu's surface held organic compounds, hinting at the building blocks of life, alongside materials useful for mining. These missions didn't haul back tons of ore, but they showed we can reach asteroids, touch them, and bring pieces home. Critical steps toward larger-scale operations. Private companies are jumping in too. In the 2010s, planetary resources and deep space industries made waves with plans to scout and mine asteroids. Though both faced funding issues, their ideas live on in startups like Astroforge, which aims to launch mining missions by the 2030s. Even SpaceX, with its reusable rockets, is lowering the cost of getting to space, making asteroid mining less of a pipe dream. The race is on, and the finish line could redefine our future. If we crack the code on asteroid mining, the rewards could be staggering, for Earth and beyond. On our planet, rare metals from asteroids could ease resource shortages. Platinum and iridium are vital for green technologies like hydrogen fuel cells and solar panels, but they're scarce and expensive. A steady supply from space could drive down costs, making sustainable tech more accessible and boosting industries from electronics to healthcare. In space, the benefits are even more transformative. Water from asteroids could become the fuel of the future. By splitting it into hydrogen and oxygen, we could power rockets, enabling missions to Mars, Jupiter, or even further without lugging fuel from Earth. This would slash costs and make space travel routine. Imagine gas stations in orbit, powered by asteroid ice. Water also means life support, air to breathe, water to drink, and shielding against cosmic radiation for astronauts. Then there's construction. Iron, nickel, and silicates from asteroids could be used to build space habitats, solar farms, or spacecraft, all without the massive expense of Earth launches. Picture a factory in orbit, 3D printing structures from asteroid materials. This could pave the way for permanent bases on the Moon, colonies on Mars, or even floating cities in deep space. Asteroid mining isn't just about wealth. It's about building a future where humanity thrives beyond Earth. Asteroid mining sounds incredible, but it's not without obstacles. Technologically, we're still figuring out the basics. Operating in microgravity is tricky. Tools that work on Earth might fail on a spinning asteroid. Some asteroids are solid rock. Others are loose piles of gravel, crumbling at the slightest touch. Dust is a nightmare, sticking to equipment and wearing it down. We'll need robots that can adapt to these unknowns, controlled by AI smart enough to handle tasks millions of miles from mission control. Distance is another hurdle. The asteroid belt is far, anywhere from 100 to 300 million miles away depending on orbits. Communication delays mean robots must act independently, requiring breakthroughs in automation. Energy is also a problem. Mining equipment needs power, likely from solar panels or nuclear reactors, both of which add complexity to missions. Then there are the ethical and legal questions. Who owns an asteroid? The 1967 Outer Space Treaty says space belongs to everyone, but it's vague on resource rights. The United States and Luxembourg have passed laws allowing companies to keep what they mine, but not all nations agree. Could a single corporation claim $1 trillion asteroid? What if mining disrupts space ecosystems we don't yet understand? And on Earth, flooding markets with cheap metals could hurt mining-dependent economies. These debates are just beginning, and they'll shape how or if asteroid mining becomes reality. If asteroid mining takes off, it could, well, reshape the global economy. Rare metals could make high-tech goods cheaper, from smartphones to electric car batteries, driving innovation and accessibility. But there's a flip side. Countries relying on terrestrial mining, like those exporting platinum or cobalt, could face economic upheaval. Balancing these impacts will require careful planning, maybe even international agreements to share the wealth. In space, asteroid mining could spark a boom. Lower costs for fuel and materials would make missions more ambitious. We could see telescopes the size of cities, built from asteroid iron, or fleets of spacecraft exploring the outer planets, refueled by asteroid water. These advances could create new industries, space construction, asteroid prospecting, even space law, generating jobs and opportunities we can't yet imagine. Culturally, the idea of mining asteroids really taps into our sense of adventure. It's like a modern gold rush, inspiring stories of pioneers not on Earth, but in orbit. For young people, it could ignite a passion for science and engineering, much like the Apollo missions did decades ago. The dream of harvesting space's riches isn't just about profit. It's about pushing humanity to reach further than ever before. What does the future hold for asteroid mining? Well, in the short term, expect more exploratory missions. NASA and private companies are already planning to map near-Earth asteroids, identifying the best targets for mining. Advances in robotics, like swarm drones and autonomous drills, will make extraction more feasible. Reusable rockets, pioneered by companies like SpaceX, are driving down launch costs, bringing the economics of asteroid mining within reach. In the decades ahead, we might see the first commercial mining operations. Small startups could target water-rich asteroids to supply lunar bases, while larger players go after metal-heavy ones for Earth's markets. By the end of the century, asteroid mining could be a cornerstone of a space-based economy, supporting everything from scientific research to interplanetary colonies. Looking even further, asteroid mining could be the foundation for humanity's spread across the solar system. With resources in hand, we could build outposts on distant moons, send probes to the Kuiper Belt, or even dream of starships powered by asteroid fuel. It's a vision that turns science fiction into science fact, one rock at a time. Asteroid mining is more than a bold idea. It's a glimpse of humanity's future among the stars. From platinum that could power our industries to water that could fuel our dreams, these cosmic rocks hold the keys to a new frontier. The challenges are steep, from technical hurdles to ethical dilemmas, but the rewards are worth it. A world where we don't just visit space but live in it, build in it, thrive in it. The next time you look up at the night sky, think of those silent asteroids drifting out there. They're not just relics of the past. They're the treasure map to our tomorrow.